Okay, so we're going to go straight in because of time is short on this stuff, so we can get into it. And you'll notice that we started at question 7, which we went through, and at least one of you noticed that I did a silly here. So the area of a triangle is base times the perpendicular height, isn't it? And I did the base times this side here, which is not right at all. So I should have had this, and this was 16, wasn't it? So instead of having a 20 there, I should have had 16. And if I did that, well, I could halve the 16 to 8 and do 8 times, or I could do 12 times 16. Either way, it should have been 192 centimeters squared. So sorry about that, folks. That's what that one should have been. Right, now I'm afraid this kind of question is on the increase. It's all about making things as simple as possible. We don't know the value of R, could be anything. And the value of G and M are not changed, they could be anything. I'm going to start by making it simpler for myself by saying that GM equals X. And then I'm going to say, right, R could be anything. So let's go for the simplest number out there of 1. So I'm going to pretend that G is equal to X over 1 squared, which is X divided by 1, isn't it? It means it hasn't changed at all. So we're only looking to see how much something changes if we decrease by 20%. Now, 20% of 1 is 0.2, isn't it? So if it decreases by 0.2, you ended up with 0.x. So I'm going to say this time we're going to have G is going to equal 1 divided by 0.8 squared. I whack that into my 0.8 squared into my calculator, and I get X over 0.64. So what I want, if I divide something by 0.64, how much bigger does it become? And it doesn't matter what this number X is, that may as well be 1. What we're worried about is we are doing the act of dividing by 0.64. I'm still a bit confused, so I'm going to say I know how to divide by a, in fact I could do that in a, I know how I could turn it into a fraction and say I'm going to times by 100 over 64, and then just put that into your calculator, and if you do that, 100 divided by 64, you get 25/16 or 1.5625. Now if 1 was what we started off with, it's going to be this much bigger. 0.5625 times 100 would be 56.25%, and that is the answer. It'll work with any other numbers. If you think you've got a nicer way of doing it, please do let me know and I'll share it with the class. Right, area of the triangle BCD. This is quite a... Before I go anywhere, I'm going to just remind myself of the formula for the area of a triangle, because I think I'm probably going to need that, where it's a half AB sin C. These being the two, if you've got a triangle that is A, B, C, so your side A would be that side there and that side there. So it's when you've got two sides either side of an angle. That may well come in. I'm just going to do easy stuff that I know. I know this is to do with angles, and I know I've got a triangle there. So 70 plus 74 is 144. 180 take 144 is 36. So that's 36 degrees. Now, it's got parallel sides. So as it's got parallel sides, because of alternate angles, they will be the same. So that's 36 degrees. Now that I know that, all I need is this side here, and I can do this to find out the area of triangle BCD. So I'm going to need to use a bit of trigonometry again to work that out. And the one that it's going to be is going to be the sine rule, because I've got that one with that one, and I can have that one with that one. If you remember, the sine rule is A over sine A equals B over sine B equals C over sine C, and you can do them all the other way up as well, and you only need two parts of it. So that's going to mean I've got 39 over sin 74 is going to be equal to, if I call that length there that I want to know, x over sin 70. Then a fairly simple bit of rearrangement, multiply both sides by sin 70, and I get 39 sin 70 over sin 74 is equal to x. Now you have to be a little bit careful putting it into the calculator, because when you open up the sin you get a bracket. Now you've got to close that bracket, then go down below sin 74, close the bracket, press equals, and I get 38.12 degrees. I'm going to use all of that accuracy in a moment by using the answer button. So then we've got this up here for our area. So our area is going to be our two lengths. It's going to be a half times our lengths of 52, 38.12, which I'm going to use the answer button for, and then sin, and the angle is 36, so sin 36. I'm going to pop that in the calculator like this: 1 over 2 times 52 times answer, because that's my previous answer, sin 36, and then I don't need to worry about accuracy. That gives me 582.6. It says 3 significant figures, so I've written it down to 4 significant figures so that I can then pop a box around there just to make sure I get this right, and the 6 means it rounds up to 583 centimeters squared. Now question 16 is related to all the similar shape stuff we've been doing. If the height is 10 times the size, then the volume would be 10 cubed, wouldn't it? So that's what I would give as my reason. If the height, so it's no, so you have to have no, but you don't get the reason unless you put in a reason. If the height was 10 times, then the volume would be 10 cubed, or 1,000 times bigger. It does say in the mark scheme that if you've put 2.15 times, because 2.15 cubed is very, very close to 10, so you may have done something like that. The surface area of shape B is 72 centimeters squared. Work out the surface area of shape A. So here, because the volume is 10 times bigger, that means that the scale factor must be the cube root of 10. And if you put that into your calculator, you do get 2.15 something. And we want the surface area, so the surface area is going to be smaller, so we're going to have to do 72 divided by the scale factor, which is the cube root of 10 squared. So if I do that in the calculator, 72 divided by, I'm going to put it in brackets just to make sure, cube root of 10, come out of the bracket, squared, equals, and I get 15.4 0.51, so 15.5 centimeters squared to 3 significant figures. So question 17 is a bounds question. It's all about whether or not we've got enough potatoes to fill the sacks. So the total amount of potatoes divided by how many you need for each sack is going to tell you how many sacks you're going to need. So the biggest divided by the smallest value will give you the biggest answer possible, but the smallest answer you will get with the smallest value divided by the biggest will give you the smallest amount. And we want to know, does it definitely have enough to fill 2 sacks? So if we do that, that's going to give us our biggest amount of sacks. This will give us the smallest amount. But whether you've thought about that or not, the first thing to do whenever you've got a bounds question is just to make a bounds grid, because you'll get a mark, just get at least 1 mark just for doing this. So you've got your 2,500 kilograms, your 12.5, and you need your upper bound and lower bound, and it's important that you look at being to the nearest 10 kg and 0.1. Then you draw your number line, and they should look something like this. Now for the 2,500 it's a little bit sneaky because you've got 2 zeros. Some of you may well have gone up to 2,600 and gone for 2,550, but it's not going to be that much. It's halfway between that and that for the next 10 kg. So that means your upper bound is going to be 2,505 and your lower bound is going to be 2,495. For here it's going to be upper bound 12.55, lower bound 12.45. So the smallest number of sacks you could possibly get are going to be when your smallest weight of potatoes is going to be divided by the largest weight of potatoes in each sack. So pop that into your calculator and you should get 198.8, which means not quite enough to fill 199 sacks. So then you say no. At that point the no gets you get 2 marks for all this working, and then a third for that working with the no, and you can get a mark just for if you've got at least one of the bounds. You get a mark. Kelly's assumption is wrong. 12 kg is measured correct to the nearest 0.5 kilograms. Explain how this could affect your decision in part A. Well, if it's out by 0.5 kilograms as opposed to 0.1, that just means the margin for error is bigger. So if you didn't, so it could be even more that it can't do. So it won't affect it. It won't affect it as it just increases the margin for error, and you just need to put some sort of validation of saying why it won't make a difference. Okay, well this is a tricky little bit of algebra, but basically remember, whenever you've got something that you could factorize it and expand when you can, but this is going to be about factorizing because we can simplify by crossing things out. So we've got the x minus 1 there, and we're taking an over x minus 5 there. Now there's a bit of a clue as to what's going to happen because we've got the minus 5. We've got to come up with what's this factorized. Well, 5 times 1 is 5, so but adding up with negative 5, it's going to be a positive and a negative. So 5 ones are 5, negative 5 plus 1 is going to give you negative 4x. So that's what we get to there. Now, in order to take this fraction from that, the denominator needs to be the same, which means we could get the same common one if I multiply top and bottom of this fraction by x plus 1. So I'm just going to write that all out now. X plus 1 x take 5 minus 2 times x plus 1 over x plus 1 x take 5. So that is going to give us, with x plus 1 x take 5 on the bottom, 3x minus 1. I'm going to expand that bracket now. 3x times 3 gives us that. And then my negative 2x, but we're also going to have to take 2 times 1, so that's minus 2. Then if we simplify what's on the top and keep the bottom the same, 3x take 2x is x, negative 3 take 2 is negative 5. Oh, x minus 5. I can now divide top and bottom by x minus 5, giving me 1 on the top, and x plus 1 times 1, which is just x plus 1 on the bottom. So that's basically done. It is 1 over x plus 1. If you didn't get it, just rewind and watch it again. Take your time until it makes sense. This is not as nasty as it looks because you've got the formulae here. We want the total surface area of the solid. So we want half a sphere. So the surface area of the sphere is 4 pi r squared. If I halve that, I'm going to get 2 pi times r squared. My radius is 3, so that's 2 times 3 squared is 9. That's going to give me 18 pi for the hemisphere. And then all I need to do is add the curved surface area of the cone on. Now, they haven't told, we know what the radius is. We need to know this length here, and we need to know that there, which we can get from the volume of the cone. So the volume of the cone is 30 pi. We know pi, a third pi times 3 squared times h. So if I simplify that out a bit, I get 30 pi equals, well, that's 9. A third of 9 is 3, so it'll be 3 pi times h. I can divide both sides by 3 pi, and I get 10 equals h. So the height is 10 centimeters. So I'm going to pop that in there as being 10 centimeters. Now that is a right angled triangle. So we can use Pythagoras' theorem to say that the hypotenuse will be 10 squared plus 3 squared, the square root of. And at this point I'm thinking that's not a nice number, so I think I've done something wrong. So the volume of the solid, not the cone, is 30 pi. So actually 30 pi is going to be the volume of the cone, which we've got there, which is 3 pi h, plus the volume of the hemisphere, which will be half of that. Well, half of 4/3 is 2/3, so I could write 2/3 pi times the radius cubed. So that's going to give us 30 pi equals 3 pi h plus 3 cubed is 27 divided by 3 is 9. So that'll be 2 times 9 is 18 pi. So now if I take 18 pi away, that gives me 15 pi equals 3 pi h, which means I can divide both sides by 3 pi, and so 3 into 15 goes 5, and pi into pi goes once, so 5 equals the height. So now we have a much more normal looking cone here, and this is a Pythagorean triple because 5 squared plus 3 squared is 25 plus 9. Hang on, I'm still rushing and making mistakes, aren't I? 30 take 18 isn't 15, it's 12. 12 divided by 3 is 4. So the height is 4. I'm really sorry about this, folks. So that's 4 centimetres. 4 squared is 16 plus 3 squared is 9 makes 25. The square root of 25 is 5 centimetres. So the length there is 5 centimetres. And that means we can now do the surface area by doing the pi times 3 is the radius times the sloped side is 5. 3 times 5 is 15 pi. So the total surface area is this one plus that one. 18 plus 15 equals 33 pi centimetres squared. Got there in the end. Simultaneous equations, where one of them is a quadratic, we need to do by putting in one of these into here. So what do I mean by that? I mean I already know that I've just got y there, so I'm going to turn my y into an amount of x's. If I add y to both sides, I get 2x equals y minus 2. If I add 2 to both sides, I get 2x plus 2 equals y. I now substitute my 2x plus y for the y that we've got there. So let's do that up here. I can now say 2x plus 2 equals 2x squared, take 3x, take 10. And you solve any quadratic by making it equal 0 first of all. So I'm going to take 2x from both sides, and I'm going to take 2 from both sides. 2x away from negative 3x is negative 5x. 2 from negative 10 is negative 12. And then we need to factorise that. Now you may remember that we have to do 2 times negative 12 to say we are looking at negative 24 for our product equals negative 24, and we want the sum or the difference between the two numbers that multiply to make negative 24 to be 5, and then it'll be negative 5. So 8 times 3 is 24. So I'm going to say that 2x squared take 5x take 12 equals 0 is the same thing as 2x squared take 8x add 3x, because that makes you negative 5x take 12 equals 0. I then factorise those two separately. 2x goes into both, so 2x take 4 there. This means that we'll also have x take 4 there. What do I times by? By 3 to get 3x, and by 3 to get negative 12, so that works. And that's my other bracket. So I've got 2x plus 3 and x take 4. Running out of ink, back in a moment. Equals 0, and then the brackets have to equal 0. So 2x plus 3 equals 0, or x minus 4 equals 0. Just rearrange this one quickly. 2x equals negative 3, so x equals negative 3 over 2, or x must equal 4. So those are your two answers, and you can leave it as a fraction or you can leave it as minus 1.5. It doesn't matter. However, I still need to pick up my y values, don't I? So now I have to substitute back in, probably take the easiest one that we've got. I've already rearranged this like this, so I'm going to put negative 3 in. So y is going to be 2 times minus 1.5 plus 2, which is minus 3 plus 2, which is negative 1. So I'm getting one result where it's x equals negative 1.5, y equals minus 1. And then the other one will be what happens if I put 4 into 2x plus 2. So y equals 2 times 4 plus 2. 8 plus 2 is 10. So our other solution is x equals 4, y equals 10. Strange looking question this. So if I rotate it 180 degrees about 2, 2, I get this shape here that I've just shaded in like that. So how many of the vertices are invariant? That means not different, not varied. And you might want to say 3 because you've got that point, and that point. But this point is actually where that one was, and that one has swapped with this one. So the only one that's in the same place as it was is that one. So your answer on that has to be 1. Now there's no getting away that this is quite nasty, but it's saying two transformations, A and B are invariant, so it's going to end up there. The first one is a reflection of the line y equals k, where it's not k equals 1, so you can't just do that because it would already be in the right place. But it's going to be something parallel with that, so it could be in 0, 0, which would flip it down to there, and then you would need to move it back up. So let's just pretend it was that. It would be flipped down to here, and then we would have to move it back up, wouldn't we? So it would have to be translated, and you get 1 mark for saying translation, by 0 because it's not going anywhere to left or right, and it would be going up well, in this case it would be going up 2, because that would get it to this point here, which is what you need. So it would be that if it was in that line, but if it was in this line here, that would flip it down further, and you would have to go up 2 more, 2 times k. I'm not going to explain it too much, but the total thing should be 2 minus 2k. Strange one, only 2 marks. Don't worry too much if you didn't get it, but just the word translation would get you 1 mark, and then don't worry too much if you didn't follow the second bit. It's only 1 mark. It's very unlikely to come up like that another time. Question 22, almost final question. Write down a possible equation of the graph. So this is about recognizing graphs. Don't worry too much if you didn't get this, but y equals sine x looks like that, y equals cos x looks like that. This is actually a reflection of y equals cos x, so y equals negative cos x would actually be one possible one. There's a few others, but don't worry about it if you're not sure what's going on here. Then the answer to this one is that this is the cos graph, which has just been shifted along 45 degrees. So the P would be 45 because it acts the other way. Again, I'm not going to go into it in detail right now. And the value of R, that has moved the whole thing up 1. So R is 1. The key to this is completing the square, which we've done a bit of. So if we have a go at completing the square here, we've got to take the factor of 4 outside of there first of all. So 4 goes twice into 8. So we do that with the big bracket. Then we halve the number of x's and square it. And then remember that we've got to take away that squared and the plus 7 outside it. Then if I remove this bracket, I get x minus 1 squared. And that will be minus 1 because 1 squared is 1. 1 times 4 is 4. So that's going to get us 4 x minus 1 squared plus 3. And then what you need to point out, just to get the last mark, is that because all square numbers are positive, 4x minus 1 squared must be greater than or equal to 0. Therefore, 4x squared minus 8x plus 7 is bigger than or equal to 3. It's always going to be positive. And that's the end of it. So add it up, see how many marks you've got. Let me know, and remember, in order to get a grade of any sort, so that would be a grade 3, which I know none of us are interested in, you would need 8 marks, a grade 4, 13, a grade 5 for 23 marks out of 80, a grade 6 for 33, a grade 7 for 43, a grade 8 for 55, and a grade 9 for 67. Now obviously we can't count this because you've just done it in your own conditions, but it gives you an idea, and I would be interested to know how you got on. So if you could upload a little bit about that, that would be brilliant. Okay, cheerio.